Thank you for joining us again here on Aviation News Talk for a Newsmakers episode, where we talk to people in aviation who are making the news. Now, when it comes to avionics, most pilots feel that more is better, but they often can't afford to upgrade their instruments. But now there's an easier, lower-cost way for pilots to add glass panel-like instruments into older aircraft. And in a moment, I'll be sitting down with Joe Gepner, who's a software engineer for Garmin, and I'll be asking him for details about Garmin's recent announcement that their G5 electronic flight instrument can now be installed into certificated aircraft. All this and more, and this Newsmaker episode starts now. Welcome to Aviation News Talk, where we talk about general aviation. I'm Max Truscott, and if you enjoy the show, please tell your friends. Before we get started, let me tell you first a little bit about Joe. He tells us that he grew up on a farm and loved to build stuff and take things apart, plus he was always fascinated by airplanes. He started programming computers in high school and then went to Kansas State University on a scholarship to become a computer engineer. And that worked out pretty well for him because he graduated summa cum laude. Now, during college, he did an internship at Boeing on the F-18 Sidewinder missile project. But during his senior year, he learned about Garmin and started working with him in 2002, working first on every aspect of the Garmin G1000. In 2011, he joined the team working on the G3X system for non-certificated aircraft, such as experimental and light sport aircraft. He designed the Autopilot servos and the AHRS, which is the Attitude Heading Reference System, which you can think of as that black box that replaces the 3 gyros you find in round gauge aircraft. Around that time, he decided to learn how to fly, and he did it in a Cessna Skycatcher equipped with that same G3X system he works with every day at Garmin. Becoming a pilot was one of the most exciting things I've ever done, he says. It made me a better engineer, but more importantly, it opened up the sky to me. My favorite thing now is taking my kids flying and seeing the amazement in their eyes. Joe is also building a Vans RV-8 aircraft, and he plans to fly it someday with the avionics that he helped design. Well, Joe, I'd like to officially welcome you to a Newsmakers edition of the Aviation News Talk podcast. We're excited to have you here.
Yeah, thanks for having me.
This is great. So I'm sure a lot of people are not familiar with the G5. So just describe it for me in general terms. Just what is the G5?
Yeah, sure. So a few years ago, we were kind of going through our G3X system for the experimental aircraft and looking for missing features or new things we could bring to the table. And we decided one missing component was some kind of backup instrument. We wanted a battery-powered backup instrument that would still function if you lost your main electrical system or your system went down. So the G5 was kind of born out of that. We decided we wanted something that would run for 2+ hours off of a battery and provide all the information from your standard 6-pack to get you down safely if something happened to your main EFA system. So we started there, and we wanted to make it affordable so that everybody would be able to, actually install it. And really wanted to get the G5 to where it was just standard equipment for any experimental aircraft that was going to fly IFR. About 90% through the G5 development, we kind of felt like we had something really awesome, and we wanted to push it a little bit further. So that's where we decided, hey, we could put 2 of these in an airplane and end up with, an AI and an HSI. And then in the experimental world, we even thought we could connect it to our servos and end up with an autopilot system. So for 2 G5s and 2 servos, you ended up with really a fully featured instrument panel with an autopilot for very low cost, very low weight. And that's where we started in the experimental world. And then it just sort of took off from there and grew over into the certified side.
Well, that's interesting. I want to dig into that a little bit more. You said that the original concept was as a backup instrument. I'm guessing today that you look at it as much more than that. In other words, if someone had a 1970 Cessna 172, they could replace their primary instruments and use these as primary instruments?
Yeah, exactly. Like nowadays, I fly a 1963 150. And I've got an old school AI, an unslaved DG, and I would love to swap those out and put in a pair of G5s. With the modern representation of your 6-pack there, that can really reduce your scan and give you a lot of information in a small area. Also having modern features like altitude bugs, heading bugs, things like that, airspeed trend. I just really think it's a lot easier to fly with. So yeah, I think you can pull those two instruments out and really get a taste of what like a guy would get out of a big expensive G1000 or something in a very small and affordable package.
So you had mentioned a moment ago the original concept backup instrument could run for 2 hours. So my guess is right now it's set up so that it would get power from the aircraft and it would run forever as long as the aircraft is running. And then if your electrical system were to fail, it would still run for another 2 hours?
Yeah, that's exactly right. And the G5 has just surprised us all along the way. We designed it to run for 2 hours, and we wanted to keep it low cost and low power when we were designing it. And we were all done, and it now runs for 4 hours with off of a battery, which was way more than we expected. And that's even with the primary battery draw is the backlight. So in the daylight, we have that backlight turned all the way up so it's nice and bright and readable in the sunlight. But if it's dimmed down, like for night flying, the battery will last way longer typically than your aircraft can hold gas.
Wow, that's pretty neat. So just describe physically, what this instrument looks like obviously this is a podcast. You can't hold it up and show it to me.
Right. Yeah, so it's designed to go into your standard 3 1/8 inch hole. It's not very deep. It protrudes from the panel towards the pilot about a half inch. And then on the back side, it really the only thing that sticks out on the back is the battery, which is probably about half the size of a deck of cards. It's about, 2.5 inches long and maybe 1.5 inches wide. Mm-hmm. And then you just connect in your pitot and static lines on the back and power and ground. On the front of the unit, it's got a big, bright, square display. And then it really just has one control, one knob that you can turn and then also press. And you use that on your AI primarily for setting your baro. And then on your HSI, that's going to default to your heading bug.
Okay. So let's talk about having it configured as, let's say somebody had just one of these in the aircraft and they were using it as an attitude indicator. Just go ahead and list all the other instruments that it's going to display on that instrument.
Yeah, sure. So I'm looking at one now, so I'm kind of cheating. So obviously we've got your attitude indicator there. That's the primary thing in the middle. And then on the top, we'll have heading or track tape. It's heading if you install one of our magnetometers. If you don't install that, then it has a GPS receiver built in, and it will show you track, which is gyro aided, so it's nice and smooth. On the left side, you've got your airspeed indicator, and that also has all your airspeed colorings, and then also your V speeds as pointers on there, so like VX and VY. We also show on the bottom left your ground speed, because it has that GPS receiver. We'll show your slip skid indicator as a ball, and your turn rate coordinator on the bottom in the middle. And then on the right side, we've got your altitude tape with altitude bug or pre-selector, your baro settings on the bottom right, and then on the very right is the vertical speed indicator, which shows up as a magenta line that slides up and down to show you how many feet per minute you're climbing or descending.
That's really remarkable for one instrument. So in a sense, this really is a mini display that you might have in the G1000, just kind of shrunk down with slightly fewer features.
Yeah, that's exactly right. I mean, it looks like a miniature primary flight display from our G1000.
So what about the autopilot type features? You mentioned that you'd need servo motors. Are you saying essentially that the whole autopilot functionality is built into this instrument?
Yeah, what's neat about it is that all the autopilot functionality, including the flight director, is built into the unit. So for the experimental guys to add the ability to, have an autopilot, they just connect two servos. It's just two wires into the unit via our CAN bus is how we communicate. That we have a CAN network. And then the servos are actually smart also, and they're able to take the attitude data from the G5 and then fly the aircraft to the appropriate pitch and roll commands coming out of the flight director that the G5 is calculating.
Now, you mentioned for experimental type aircraft. What about certificated aircraft? Can they use the autopilot function as well?
They can't now. That would be an STC update. The FAA, is currently changing and looking at allowing non-TSO'd equipment into certified aircraft, where if they meet the performance requirements, then that's something that they'll allow you to STC into the aircraft. That's how the G5 got in there, initially, because it doesn't have a TSO, but we did prove that it meets all the TSO performance requirements. So it was allowed to be STC'd into those certified airplanes. So that's something that, Garmin's, we're always looking for the next thing. So we've definitely heard that autopilots for the lower end of the fleet is something that people are excited about. So that's something we'd like to look into also.
Yeah, I'm a huge fan of autopilots, and I think that that's probably the biggest safety item that anybody could add to an aircraft is, the ability to have that device take over and, let you focus on other things while you're flying rather than just trying to keep the wings level.
Exactly. Yes. Yeah. I'm actually doing my instrument rating right now, and boy, when my instructor lets me use the autopilot, the whole thing sure does seem a lot easier.
Yeah, it does. Yeah, I always think that we ought to use our brain for thinking about the hard stuff and let the autopilot take care of the the simple stuff that
exactly.
That really takes up a lot of our brain cycles. So tell me about the GPS that's built into this. That's kind of surprising. And when you think about a traditional attitude indicator, GPS doesn't come to mind. What function does that provide?
So the way these digital gyroscopes work, they're solid state, and they work really, really well. But the old spinning mass ones, they're really fantastic as far as like drift goes and things like that. Now we all know the spinning mass ones, they don't fail in a nice way. They take service and things like that. So really, these solid state digital gyros that nowadays drive the AHRS in most modern EFA systems, they do require some form of aiding. And what we're doing there is, over time, we look for where gravity is, and we slave those gyros so that they don't just coast off and give you some misleading attitude. And gravity is what we're looking for, but unfortunately, there isn't any affordable device that measures gravity. Instead, we have accelerometers, which measure acceleration. And as you know, when you fly an airplane, acceleration can come from other forms than just gravity, from your centrifugal force or your linear accelerations and stuff like that. So we use GPS, or we can also use airspeed to try to figure out which accelerations are coming from gravity and which accelerations are coming from you maneuvering the aircraft. And what we do is we take an acceleration measurement and we remove the non-gravity-based accelerations from that measurement, and all that's left is gravity, which always points down. And then we're able to use that to slave or correct the gyros from drifting. So GPS is one of our two means of aiding in the G5. We use GPS as a primary means of aiding because that decouples it from your pitot-static based instruments. And then if we detect that there's something wrong or missing with the GPS data, then we can, as in a backup case, use air data, airspeed for aiding those gyros.
Wow. Okay, super. So you've given us a great explanation for how the GPS gets used, or why it was initially put there to make the gyros and the AHRS track better over time. Is there a way that a user can access that GPS for traditional GPS functions, such as moving map or things like that?
No. So the G5, to keep it affordable and also just make it so there's no ongoing cost to owning a G5, we decided to build it without any databases. So it doesn't even really know where, Kansas or California or anything is. We just have from that GPS signal, we're able to tell you ground speed and track, but we don't put up a moving map because we don't have a database that tells us, where the states and airports and everything are.
Right. And I guess a typical user who might put this in an older aircraft might perhaps be bringing along an iPad with software, which is going to show them where they are anyway.
Exactly. Yeah, that's kind of our thought. There's so many good ways of, seeing charts and moving maps and everything, from navigators to portables to iPads. We just didn't want to solve a problem that we didn't know necessarily existed. And we didn't want to drive up the cost or, cost of ownership of the G5.
Okay. So when we say that the G5 includes GPS from a user standpoint, it's not a traditional GPS they can use. It's kind of hidden behind the scenes and doing other things.
Yeah, the only benefit the pilot gets is track and ground speed.
I got it. Well, those are pretty helpful.
Yeah.
So tell me about the differences between models. We've been talking primarily here about an attitude indicator replacement, but I think you've also got one that could replace a DG or a heading indicator. Tell us about that.
Yeah, so that's absolutely true. And one really cool thing about the G5 is there actually isn't any difference in the models. So basically, you buy two of the same things, and you can install one as an AI and one as an HSI or a DG replacement. And what's cool about that is if your AI were to fail, your DG or your HSI G5, you can change it back. You can change its display so that it is now the primary flight display representation, or an AI. So if you're flying along with two of these instruments and one of them goes down, the other one can still provide you your full 6-pack type of information with, air speeds and everything. So there really isn't any difference in the models. They're all the same exact part number. The only difference is when your installer installs them in your aircraft, he'll say what its primary function is, and that's going to basically inform the unit which page to show you at power up. But then you can actually change it to, on the DG or HSI, you can actually change that back to a backup AI representation if you ever needed it.
Okay, so essentially, if we've got a certificated aircraft, then we've got potentially two G5s of the same model number. What if we have a non-certificated experimental aircraft? Now, that's a different model number, isn't it?
So the way that works is we sell an STC kit of the G5 that includes all the STC paperwork and things you need to complete that STC. And it is sold for a little bit more money to try to allow Garmin to recoup that cost of certification and flight test and paperwork with the FAA. So there are two separate part numbers that you would purchase, whether you're an EAB customer or a certified customer. The actual G5 piece of hardware, though, it's actually the same thing.
So you brought up cost. Everybody seems to care about cost for some reason.
Right.
Let's talk about that. Suppose we've got an experimental aircraft. What kind of cost are we looking at?
Jess might have to help me out, but I think it's $1,100 for an EAB guy, and then I think it's $2,100 for the STC version. Okay.
And what about servos? So, for example, if it were an experimental aircraft, do you sell the servos, and what do those cost approximately?
Yeah, we do sell the servos, and those retail for $750. So that's one of the really exciting things I feel like that I would love to get to grow from the experimental world to the certified world, where we were talking about how much of a safety enhancer and a workload reducer an autopilot is. And for an experimental guy, if he already has a G5, he can add a 2-axis autopilot for just $1,500. It's really pretty amazing.
Wow. And if he or she doesn't have a G5, we're looking at, you said, about $1,100. And you could actually buy just a single G5 plus the servos, and you'd be looking at under $3,000 for an autopilot plus the flight instrument.
Yeah, it's so amazing, and that's why I think it's really exciting to start to bring this to the certified world, because it's so affordable that really anybody can do it now.
Yeah, that's mind-boggling. That's just that's remarkably inexpensive.
Yeah.
So let's talk about certificated aircraft. I know you have a really long list of aircraft that are on that. Tell us about that process, roughly how many planes are on it, and if there are any types of aircraft that might not be on it.
Yeah, so our AML, I think we were over 500 aircraft on that approved model list, and it's always growing. I think I heard that you've got a LA4 amphibian. Is that right?
That's true. I do have a lake amphibian.
Yeah, so I heard through the grapevine that that's on the short list to get added to the AML.
Aha.
And one thing, like if a customer has an aircraft that is not on the list and they'd like to see if we could get it on there for them, the best thing to do is to contact our aviation support team. We've got an email. It's aviation.support@garmin.com that anybody can email, and they can talk to our product support guys. They're awesome, and we'll look at getting those airplanes on the AML if it can be done. Like if you privately own a 747, we're probably not going to be able to get something like that on there. But if it's anything that the G5 can handle and was designed to be an instrument for, really, it should be pretty simple for us to get that added to the approved model list.
Okay, and so I'm guessing that the most common type models, Cessnas, Cherokees, things like that, Beechcraft, those are already on the list?
Yeah, they should be, yeah. We hit the ground with over 500, and it's been growing, and certainly all the kind of normal aircraft that have sold many thousands, they should all be on that list.
And I presume if somebody wanted to buy a G5, they would go through their local avionics shop?
Yeah, that's right. Yeah, any of the Garmin dealers know everything there is to know about G5s and can help you purchase one and get it installed for you.
And what about installation time and cost, which is obviously related to time?
Yeah, no, that's a great question. I was talking to one of our dealers at Sun and Fun, and the G5s have been really popular, so they said they've really kind of got it down to a science to where you drop your airplane off in the morning. They have one technician that does the install through the day, and then you pick up your airplane that night. So he said it takes them between kind of 6 and 8 hours, and he said it's pretty much the standard cost for them that they charge a customer is $1,000. You don't have to modify your panel; it goes right into that 3 1/8 inch hole, and they do tap it into your pitot-static system. So they'll go ahead and do an update to your pitot-static check, and then they just connect it to power and ground off of your avionics bus, and you're ready to go.
Right. Now, do they flight test it afterwards, or is that something that's just assumed it's going to work fine?
No, Garmin did all the work to verify flight test performance and everything. They will level the aircraft and get the pitch and roll offset just right. But they don't even need a pilot on staff. We've done all the flight tests and everything for the instrument.
Right. Boy, this sounds like the greatest thing since sliced bread. I mean, it's really amazing to have something that's the low cost with all these kinds of features and functionality. How would you contrast it with some of the more expensive solutions that people have had to go to in the past? Things like the G500 display, which obviously, a much larger panel requires more installation because you're going to be cutting holes in the panel. What kinds of features are going to be found in something like that for many thousands of dollars more that people wouldn't find in the G5?
Yeah, the big thing is that's got a giant display with a moving map, and it can interface and drive many more third-party radios or autopilots and stuff like that. Whereas the G5 is more just your simple instrument. It does have the ability to, be an HSI and interface to digital radios. But it does, to keep the cost low, it doesn't have all that kind of older analog I/O that gives it that would give it the capability to interface to more of your existing avionics or radios or autopilots that might be in your aircraft.
Okay, that makes sense for me. Now, there's one thing that still just surprises me: just a single knob. How do you guys get away with using a single knob? And tell me about some of the kinds of things that you can change with that. I'm guessing there's no touch screen.
There isn't a touch screen, and that's probably another difference between the bigger, more expensive, fully featured EFISes. Since the G5 only has a knob, we wanted it to be nice and simple and non-intimidating. It doesn't do lots and lots of more advanced features that would require multiple knobs or touchscreens and things like that. So yeah, basically the knob is parked on what you would think it would be for an AI or an HSI. So for the AI, since you've got an altimeter there, it's sitting on your barrow adjustment, and then for the HSI with the heading bug, it's sitting on your heading bug. If you press the knob, then it brings up a little menu, and you can do a few other things. Like, for example, that's where you can put in your altitude, your selected altitude. That's also how you would change your HSI to be an AI representation. But for the most part, you just push the knob and you move it to whatever selection you want, and then you push it again and it makes that selection. There's not thousands and thousands of features that can cause it to be intimidating. So even though that sounds like you can't do a lot, it actually works really well because it's nice and simple and you can't get yourself confused.
Right. And certainly since there's no access to the GPS, you're not going to be trying to enter a 4-letter identifier with a single knob.
Exactly. Right.
And we all know how much fun that is.
Yes.
So I was thinking about that knob with the HSI. Can I select different data sources to my HSI? So, for example, GPS 1, GPS 2, VOR 1, things like that from other external GPSs or VORs that I might have installed in the aircraft?
So currently the HSI just supports a single nav source. So if that's a VHF GPS, like a 430 or a GTN, then it will show either, your GPS guidance or your VHF guidance, but you would make that source selection on the actual navigator. If it's just a GPS, like if you have a GPS and separately a VHF nav radio, then the G5 is only connected to one. So typically you'll connect your HSI to your nav 1, and then you would leave in a CDI or something like that connected to nav 2.
So are there things where you kind of look to the future and say, wow, if only we put these kinds of things in? I mean, do you see the G5 has a future growth path for it where it might get bigger and sexier with more features, or is it pretty much hit the mark for where you want to be, and you guys are going to move on to look at other things?
Oh no, we want to keep packing more features in there. So one thing that we've heard loud and clear from the market is, I was talking about how we didn't put that analog I/O in there, but when we're asking guys to replace their DG with a heading bug on it that drives their autopilot, they can't really do that if we don't have an analog heading output. So that's really high on our list to get a solution for. We know there's a lot of customers out there that would love to have replace their DG with the G5, but they need that analog heading output for their autopilot. So that's really high on the list. And then you were talking about multiple nav sources. We would like to look at the ability to actually make the HSI smarter and be able to support multiple nav inputs. So that's something we're kind of considering. And then, we've been talking a lot about the autopilot. So we know that the certified world is hungry for an affordable autopilot, and we've got this awesome system in experimental. So, that's something that we'd like to consider also for the G5 to grow into.
Yeah, that's really exciting. Well, let's switch gears just a little bit. Tell me about the RV that you're thinking about building. Have you started on that?
I have. Yeah, I've actually built 2 tail sections for RVs. I started off and I built an RV7 one, and then I started flying my wife around. I quickly realized that I would probably be doing most of my flying by myself because she kind of gets airsick. So then I thought, well, if I'm gonna have an airplane I fly by myself, I might as well make it a tandem. So I sold my RV7 tail kit, bought an RV8 tail kit, and built that. And then my kids got old enough to start to like to fly, and now they want to fly with me all the time. So now I'm wondering if I shouldn't have actually built a side-by-side instead of a tandem. So who knows? I might go back and buy another tail kit to start all over again.
Well, you sound like a busy guy. How do you do it all with building instruments, taking care of the kids, and building airplanes? Do you have any spare time?
No, pretty much. I just what's exciting for me is like what I like to do for fun. Fly, build, mess around with airplanes is also what I get to do at work. So it all kinds of blends together into this weird, fun lifestyle of airplanes and my family, and it's pretty fun. I don't really know where work ends and not work begins.
Yes, and that sounds kind of familiar since most of my world is fully immersed in aviation at that point. It's pretty tough to have a job where you kind of think, well, wait a minute, this is fun.
Exactly. Yep.
There's something wrong with this picture? No, wait, there isn't. This is awesome.
Yes.
So I'm thinking that there might be someone out there listening right now going, oh man, I would love to be doing what Joe's doing. If someone were interested in working for Garmin, what would you suggest to them as a path where they might want to, things that they should be either studying in school or, ways that they might be, looking to work for the company?
Yeah, Garmin's a big place, and we've got all kinds of different people and jobs here. I'm more familiar with the engineering side. We've got the main three sort of engineering disciplines are mechanical engineers that, design the look and feel of our boxes. If it's a servo, they're building the moving parts. And then we've got our electrical engineers that design the circuit boards. And then we've got our software engineers that's what I do. So I'm going to talk them up a little bit more. We get to put the brains in it, and we get to make the thing really do whatever its job in life is supposed to be. So, one of those classic sort of engineering degrees. And then the most important part about getting a job here at Garmin is to just be really passionate and excited about what you do. Don't just go to school and get the good grades, but find something you really love and just go after it. And if it happens to, line up with Garmin or whatever, if you're building race car engines, it's so much more fun to have a job that you're passionate about. Every day, I look forward to coming to work. And I just can't imagine doing something for a living that wasn't like that, because I've been so spoiled by having a job that I just really enjoy.
That's awesome. And most of the people are working at your location, and where exactly is that for folks that aren't familiar with it?
Yeah, so Garmin really is a worldwide company nowadays. Our headquarters is in Olathe, Kansas, which is kind of a suburb of Kansas City, over right by Missouri. And then we've got another big aviation place out in Salem, Oregon. We've got areas on the East Coast. We've got, offices in Europe and Australia. We really are worldwide.
Well, Joe, thank you so much for joining us today on this Newsmakers edition of Aviation News Talk to talk about the Garmin G5 and about things you're doing at Garmin and how much fun it is to work at Garmin. We really appreciate your time. Thank you so much.
Yeah, thanks a lot, Max.
And just a reminder, our listener survey is up now live at aviationnewstalk.com/survey. It'll be open throughout the month of June, so please take a moment to give me feedback on ways to improve this podcast. And if you enjoyed this show, please support the show in one of the following ways. Just tell one of your friends, leave a review in the Apple Podcasting app, or by signing up for one of my online courses at pilotlearning.com. I'm Max Truscott. Fly safely and keep the blue side up.